Hello, everyone. I am Kaylin from Homeschool Buyers Co-op, and I'm thrilled you're able to join us today for our fun science webinar. Please help me welcome our host, Esther Novus. Esther is the founder of the Young Scientist Club, and she's been running hands-on science camp for kids for more than 2 decades now. And so she's here to show us some really fun experiments you can do in your own kitchen. Today's format will be a little bit different for those of you who have joined us for previous webinars. Some of these experiments take a little bit more time to complete than we can really accommodate on a webinar. So what Esther's done is she's recorded this great how-to video, and we're gonna watch that together. And we recommend that you don't try to complete the experiments alongside the video because you won't really have time to execute them the full way. And rather you take this information and do each experiment in your own time after the webinar ends. And at the end of this, we'll email you this recording as well as a PDF including all of the experiments plus 2 very cool bonus experiments, making bread, and my personal favorite, the exploding marshmallow. I will begin the video shortly. While it plays, please feel free to put any questions you have in the chat box. I see a couple of you are already using it, so hi to all of you guys. Put any questions you have directly into that chat box, and then after the video, we will get to as many as time allows. So with that, I will go ahead and kick this off and we can let the science begin.
Hi there. I'm so excited that you guys are joining me today. I've been running a summer camp for the past 20 years for the Young Scientist Club, and this is the first year that we're not having camp. So I'm so excited that you will be our campers today. Our campers in all those 20 years used to come with great ideas for new science kits, and then they would test out all the experiments. Today's theme was one of their favorite topics because all the science experiments that they would do, they could actually eat. And after I finish you doing 4 of the experiments, we will be emailing you the instructions as well. So you can do these experiments at home. You will get a PDF with 6 experiments. 4 of the experiments I'll be doing today, 2 of them you can still do at home as well, in addition to the 4 experiments we're doing today. Are you ready? So the first thing we're gonna do today is make ice cream. And who does not love ice cream? So what we're going to be doing for the ice cream, you need a small Ziploc bag and a large Ziploc bag. We are going to add the ingredients for the ice cream into the small Ziploc bag. We're going to need 2 tablespoons of sugar. I'm going to do that. We're going to need 4 tablespoons of milk. Now you can make a bigger match and you can double the amount, of course, also. So that's 4. Then we're going to add 4 tablespoons of heavy whipping cream. That's more 4. And then we're going to add 2 tablespoons of vanilla, just to give it a little bit more sweetness. And obviously we're making vanilla ice cream. Now, if you have some different flavors at home, you can certainly add that as well. All right, then when I'm done with that, I'm going to close this. Make sure it's closed very well. Then I'm going to take a large Ziploc bag, and I'm going to add 2 cups of ice. And then I'm going to add 6 tablespoons of salt. Now, you might be wondering, why am I adding salt to the ice? Now salt, just like when people use salt on the ice in the winter, it actually lowers the freezing point of the ice, of water. So we're going to put that in, mix it up a little bit, and then we're going to put in these ingredients right in here. Make sure it's kind of surrounded by the ice. Now the ingredients of the ice cream freeze at a colder temperature than water is frozen. And that's why we add the salt, to lower that freezing point. And then you're just gonna hold it like this, rock it for about 15 minutes. Make sure that it gets cold because your ice cream only forms if it gets frozen, if it's cold. Now this is going to be very cold, so if you're going to touch it, you might want to wear some gloves, but you're just going to keep shaking it just like this until it becomes a solid. Now I've already made a batch just to show you so that we don't have to wait 15 minutes. So I'm going to take it out. It's a little bit softer because it's so hot outside. And then we have the ice cream that you can then put in a cup. And then you can eat it. And it's yummy ice cream. So enjoy making your ice cream. You can make small batches, large batches, whatever you want. And then you're just going to churn it. You're going to shake it. You're going to shake it and shake it until you get 2 layers in your little jar. Then these 2 layers, and I actually made one already for you. The 2 layers are a liquid. I'm going to pour some right here. Now that liquid is actually buttermilk. And then the solid that's in there, look at this, is your butter. And look, and then you put it on toast or whatever else you want to put on it, and then you eat it. Now this butter that we made, and I'm still making in this jar, is unsalted butter. If you want to add salt, you need to add that to the cream before you start mixing it up, before you start shaking it. Now once your butter is finished, you can either take it out and make a ball out of it by holding it in cold water. You can either add some honey or herbs, whatever you would like. You can make your favorite butter. And then it should last about 10 days in the refrigerator. Then if the buttermilk, you can certainly taste it if it's something you like to drink, but that might not be as good. And the reason all we need to do is churn it and make butter by shaking it is because in the heavy cream, there's a lot of fat. And by shaking it, you're breaking all these tiny little membranes that are around these fat droplets. Once those are all broken, the fat droplets then stick to each other and they make this big solid ball of butter. And that's what your butter is. So hopefully you'll have fun making some butter at home. The next experiment we're going to do, now in the little booklet you're going to get, it's called dancing pasta. I'm actually going to make some dancing raisins and craisins instead. They seem to work a little bit quicker than doing pasta, so it's a little bit easier for when we do a demonstration. So you get a cup with water, about 3/4 full, and then I'm going to add about 2 tablespoons. We'll start with that. You can always add some more of baking soda. So we're going to mix it up. You put it here so you can see it better. We're going to mix it up so that the water gets a little bit clearer. I'm going to add some more. Okay, so we're mixing baking soda and water. Right now it looks a little bit cloudy. Let's see. That's a little bit clearer soon, once it settles down. Now, with this kind of experiment, we're going to mix baking soda, and then we're also going to add vinegar. When you mix baking soda and vinegar, which baking soda is a base, vinegar is an acid. When you mix a base and an acid, carbon dioxide is formed. Carbon dioxide is a gas, which are bubbles. And gases, when they're in a liquid, like a water, they will go up because they're lighter than air. And then when they get to the surface of the water, they pop and go disappear in the air. Now, when we add something very light to that solution, see, this is a little bit. When we add raisins to that solution, or craisins, you know, whatever, or you can use spaghetti. Sometimes rice will work as well. they will sink because they're heavy. See, and they're at the bottom of the cup. Now, when I add, so we don't have bubbles yet because all I've added to the water is the baking soda. When I add vinegar, and let's see if you see anything happen. See all the bubbles? Now keep your eye on those raisins or craisins. Okay, the bubbles are going to attach to them at the bottom. I'm going to add some more vinegar. Make sure you get a really good reaction. So the bubbles that are formed attach to the raisins or craisins, whatever you use, and then they go up and they take them with them. Once they get to the surface, those bubbles disappear into the air, and the raisins or craisins go back down because they're heavier than water. Once they're back down, they can pick up some more bubbles, and then they go back up. And that will continue as long as there is enough bubbles in the solution. Now you can even try this with seltzer water, or you can always, like if it's not working, you know, in a while when there's not enough bubbles anymore, you can add some more vinegar, you can add some more baking soda, and kind of keep playing around with it. So these are called dancing raisins or dancing craisins, or you can certainly try some other things, little pieces of pasta, little pieces of rice, and see they're going up and down. So when they go down, they pick up bubbles. The bubbles make them lighter and they go up. And then when they go to top, the craisins don't actually get lighter, but because the bubbles go up because they're lighter, they take the craisins with them. Then the bubbles pop into the air and the craisins go back down. It's kind of fun to watch, right? And I can certainly keep adding more vinegar. See how many bubbles I'm making now? You'll have a lot of fun with this one. Our campus certainly always did. All right, now our last experiment, now this was always a hit. Now when we did camp, I always had lots of high school students as well as college students help out, and they had as much fun as all our campers. So I'll bet you that your parents are gonna have as much fun doing these science experiments as you will. It's a great family afternoon of science fun. So what I'm going to make today is make some chocolate slime. So all we need is cornstarch. I'm going to put a cup of cornstarch in here. We need a cup of water. Put that in there. And then I'm going to just mix it together with my hand. This actually makes your hands nice and soft too, if you keep doing this. Now, what's really cool about this slime, it's actually a non-Newtonian fluid. If I grab it, it's a solid. But then, if I let it go, it turns into a liquid. So it has both properties of a solid. A solid is something hard that doesn't flow, and a liquid that does flow. So if I take a chunk, I put it in my hands, and then look, it flows all the way down. Now, if this is not totally working for you yet, if it's too dry, add some water. And if it's too hard, too soft, add some more cornstarch. You can play around with it a little bit. You can make big batches, small batches. You can add some food coloring, but it's so much fun to play around with. Now, cornstarch, it is an edible experiment because you can eat it, but cornstarch probably doesn't taste that great. Now, what we like to do, we like to add some chocolate syrup. So we're making chocolate slime here. All right, we add some more. And we're gonna mix in that chocolate and make some really good smelling chocolate slime. Now, because I added the chocolate, it became a little bit more slimy and gooey. Now, if I want it back to, that I can grab it and it's a solid, all I need to do is add some more cornstarch. But even playing with it like this is a lot of fun. Now, sometimes what our campers used to like to do is even drop it on the table. And so they would make a big mess, but it was always fun for them to play around with it, see how easy it is to pick it up. It's very easy. You can grab it, poke it, and put it back in your bowl if you want. Certainly a good experiment to do outside. And again, look at my chocolate slime. Isn't that fun? So that is it for the 4 experiments that we're covering today. We certainly hope you had a ton of fun. And I encourage you to always do lots of science experiments. I started this company, like I said, 20 years ago with my kids, and all my kids are all grown up and they have really fun and great jobs in the science fields. And they love learning, and they just, now they do grown-up science experiments. So we hope that you get inspired by doing lots of science. And if you have any questions, let us know. And I encourage you to go to our website, youngscientistclub.com. We have a clubhouse there with lots of fun, great information. We even have a math fact creator, so you can do lots of math problems at home. You know, it is summer, but it's always fun to keep on learning. Thank you. Bye. Hi there. I'm so excited that you guys are joining me.
Hello again. So it sounds like we had a few little hiccups with the video, but nobody worry. We will send a link directly to that video just in case this recording does not pick up with as high quality as we would like it to. But thank you so much for creating that for us, Esther.
Oh, you're very welcome.
So if anybody has any questions, please go ahead and add them to the chat box, and we'll get to as many as we can. We have a few already to start out. So why do you think experiments like this are important for a child's education?
Well, I think children should start doing experiments, hands-on experiments, as early in their life as possible. You know, a 3-year-old will get something differently out of it as a 5-year-old, as a 7-year-old, but it's a great way to get the whole family involved, to spark their curiosity in the field of sciences, whether it's playing with water, whether it's playing with slime, whether it's even food related, you know, when you're having dinner or cooking. There's just so many places where you can introduce science to children. And I think it, you know, really to spark that curiosity that will set them up for a lot of success later on in life, and just give them a lot more options in what they might want to continue to study and eventually, you know, a career. You know, science careers, there's so many different variations, and it just, you know, opens up a lot of doors.
So how young do you think you can really start a child with sort of hands-on experiments like this?
So we started, we had kids in our camp starting as young as 3, and you know, some of the science kits that I had developed started actually for the, you know, the age of 3. And obviously a parent needs to, you know, help them with it, or an older sibling. But, you know, a 3-year-old is not necessarily going to understand all the physics concepts or the explanations, but they will still get excited about doing experiments, you know, and it's still better than doing a lot of screen time. So, you know, they might explode on a volcano and, you know, just get excited about doing it over and over and over again. That's a good thing about working with young kids. You can do the same experiment for hours and they're still having fun. So it's really not that much work, you know, whereas like a 12-year-old, you need to have lots of things set up for them to fill up an hour, whereas a 3-year-old, you can just do one thing and they'll be happy. So I think it's very important to start them young and early, whether it's nature walks, whether, you know, incorporating it into your daily life. It doesn't necessarily have to be a set hour every week or a couple of hours every week. You know, it's like when you go outside, have them ask questions. And if you don't know the answer as a parent, that's fine. Look it up later on when you get back home, or you know, you learn together. And that's kind of the fun thing I think about science, is that the whole family can get involved, everybody can learn, and it's okay not to know an answer. You know, we still do it at my house all the time, and my kids are, you know, in their 20s. So you know, we're always looking for answers and exploring other things.
Oh, that's so cool. How often would you suggest children do science, and specifically science experiments, as part of their homeschool routine?
As part of a homeschool routine, I would suggest at least, if you can't fit in a little bit every day, at least a couple of times a week. But even if it's not, definitely part of a little bit more of a curriculum where you incorporate maybe some reading, some math, some measurements, maybe keeping a graph, maybe you're growing something. It doesn't have to be hours every day, but as long as there's that exposure, and depending on what unit, when children are very young, I don't think anybody needs to invest in a very expensive curricula. I think you can do a lot of things at home with what you have at home, and just really get the children excited and spark their curiosity and have them go explore. And then as they get older, they will benefit from a little bit more set curriculum. But I think, when they're very young, it's just to have fun, so that they have really good experiences with learning science. And I think, especially with homeschooling, you can expose them. You're in control of what you're going to work with them on. It's a little bit different when kids go to school. So my goal has always been to give kids a great, fun experience with science. So when they do get that, science teacher that maybe they don't like when they're in school, they don't get disappointed and say they will never want to do science again, that they still have those good memories of when science was fun, and that, one teacher that might not, be their favorite does not turn them off from studying science in the future.
Do you have any advice as to how parents can sort of self-identify when their, regular day-to-day activities are something that they can incorporate science speak around, and how to do that?
Just by asking lots of questions, and have the kids ask questions. You can even just when you're cooking, it's like, why is boiling water? Why is it bubbling? What does that mean? Or why do things fall down? Who figured out that things always fall down? Why are things not going up? There's just everything you do, everything sitting on the chair is science. Why can you sit on the chair? Why don't you fall to the ground? Why? It's because there's opposite forces, and that's Newton's third law. And so there's a lot of different ways you can always, I think the most important part is to just ask and encourage your children to ask lots and lots of questions, which they might do already, and maybe they're already doing too many. But I think asking questions, and then, if you don't know the answer, say, that's a great question. Let's look it up. Let's see what we can find. And then, that's a great thing about the internet. All the answers are there, and I think it's important. We actually, on the Young Scientists Club website, we have a clubhouse where we have a lot of child-friendly links that are safe for the kids to navigate to find answers to a lot of the questions, and they are divided by themes. So, it's a little bit easier, but, there's just so much fun out there. And I think, if you do want to invest in actual buying complete kits, that everything comes in the kit, there's a lot out there as well. But I think it's also possible to, to just keep teaching at home and keep encouraging the kids to investigate and to learn and to, dig in the dirt. If you're outside, just have them dig around. It doesn't have to be in a forest. It could be, in a little patch of dirt, and just see what they can find and what they can identify, and have them, combine it with writing, have them write stories about what they find, or drawings, combine it with art. So there's just a lot of ways to incorporate science in all the other disciplines.
That's so cool. And then if you have children of a varying age range, how will you pick experiments that they can maybe all do together?
Well, that's the fun thing about science. Like when we did camp, we had children ranging from ages, like I said, 3 to about 12, but then we had high schoolers who were campers, college kids that were campers, and they were as much excited about doing the experiments as the 3-year-olds. I think the main difference is between the different age groups is that, a 12-year-old will understand more of the concepts behind an experiment, whereas a 3-year-old will see it more as, oh, we're doing science, we're playing. So I think it's a great fun family activity to do with multiple children. Everybody can help, you know, the older kids can be kind of the lead scientist and help the younger ones out, or, you know, if a 3-year-old is not writing, then someone else is going to write down all the measurements or all the results, conclusions. So you can kind of, they can work as a team. And I have to say that all the years we've run all of our subscriptions, and we always get the question, do we need multiple subscriptions? And I always say, depends on your children. And I have to say probably 99.9% of the families, do one subscription where the children all share and it works great, which is great to know, because children, they can work, they learn how to work together, and they take turns, they take turns scooping whatever chemical, or they're not real chemicals, of course, but ingredients they need to add. And then other things, they can all make their own batch, so it's, but it's a great way for them to learn how to share, how to work together. One kid might need to hold something while the other one pours something, and they can learn from each other.
Oh, that's really cool. And then one thing, I'm going to sneak in a question of my own here, so I hope you guys don't mind, but why did you decide to start creating your own curriculum kits? What were you hoping to achieve?
So about 20 years ago, when my oldest one was 5, I really felt there was just nothing out on the market that was easy for parents to follow, that was fun for the kids. A lot of the instructions were really written for much older kids, and so it made it all, and definitely not for parents without a science background. And so I just started writing experiments, started a camp. All my son's friends would show up because the parents thought it was fun, for their kids to do science. And after school program, then I had friends around the country who said, oh, I wish my kids could come. And then I had this great idea, I'll just send you the stuff. So I just sent stuff in an envelope, and it kind of started from there. And then we had, really, I think it was the homeschooling community that started that, basically this whole subscription phase of our company 20 years ago. We got written up in a bunch of newspapers, and then homeschoolers really like the idea of getting monthly subscriptions, and homeschoolers have really been a strong base for us for 20 years now, which is great. And things have definitely changed over the years. That obviously we online and internet and things that are available. But I've always been very thankful for the homeschool community, because in general they're very honest, so they will call and let us know what they like, what they don't like. That has always allowed us to make the product better, or rewrite instructions if we needed to. So that's kind of how it started. And then from there, we used the same kits and ended up putting them in retail, and now they're sold worldwide. And so it's been exciting. And for me, it's been great, because I just really want to reach as many kids and really have them get excited about science, because I just know that it opens up so many doors. And it's, especially now competing with all the screen time and iPads and TV shows, I still think the hands-on experiences is still better for a child's development.
I mean, it's amazing. You see subscription services everywhere nowadays, but you've been doing this for 2 decades. I mean, you were quite avant-garde with this. It's amazing.
So about, I think much long ago, maybe like 30, 40 years ago, there was some kind of science subscription box that I don't even know what it was called, but when I started it, I would get grandparents email or call, because like 20 years ago, people were calling, saying, oh yeah, I vaguely remember that there used to be something that we would get mailed home from some museum. And so, so we've been doing it for 20 years now. Of course, there's so many other choices out there, but I still feel, that our instructions is really what sets us apart. I really want to make sure that parents get excited about doing science as much as the kids, because if the parents don't enjoy doing it, then that kit is just going to stay in the closet, then that's not, and that's kind of what happened to my first science kit that I had for my son. And that's how I started the company.
That's amazing. Well, we have one last question, and I think it's a great one, which is, what is your favorite experiment that you've ever done with your kids?
That's a good one. I would probably say dissecting owl pellets. So we get these owl pellets, and these owl pellets, I don't know if you know, but they basically are pellets that owls spit out after they eat rodents. And then they get sanitized by the people that collect them, and you can buy them, and then you can dissect them. And you find little skulls, little bones, you clean them in Clorox, and then you kind of reconstruct the rodent skeleton. So to me, I thought that was really fun. And I have to tell you, most of the science experiments that I cover in the Science Kids, I never did as a child or an adult. So that's why it's always was fun to do them, because I never, that's not something we did in school, and I certainly didn't do at home, because you just didn't do that. When I was younger, we played outside, but that was it. Parents kind of said, play outside and come back later today, and that was it. So yeah, so it's been a lot of fun, and I still enjoy doing science experiments. I still creating all the time. My kitchen gets a mess, and then sometimes things work, sometimes things don't work, but then, once it works, that's when it goes out on the market.
Nice. Well, Esther, thank you so much for sharing your time and expertise with us today. And
thank you for having me.
Oh, it's been an absolute pleasure. And I would also like to thank all of our attendees. It's always, it's just an honor to share part of your day with you. And if you do want to keep the science fun going in your homeschool, I cannot recommend the Magic School Bus Science Kits enough. Each month you get a fun kit in a really colorful envelope in the mail, and you can do these really cool hands-on experiments with your kids. They're incredibly engaging. And for a very limited time, you can get an annual subscription at the co-op for 50% off. And if you're interested in it and you'd like to receive your first kit before the end of August, be sure you place your order before close of business tomorrow. It's personally one of my very favorite curriculums at the co-op. I just think it's so incredibly cool. So like I said, I cannot say enough about it. But again, Esther, thank you so much. We really appreciate your joining us today.
Thank you. All right, thank you.
Bye, everyone. Have a great day.
Thanks. Bye.